Hello, students, to lecture 7 of this physics course series. In this lecture, we will start from acceleration. So, we will basically study about acceleration, and we will also see the velocity time graphs. We will also see the graphical representation of acceleration. All right. So, starting from the definition, what is acceleration? So the definition is acceleration is the rate of change of velocity with time. What does this statement means? The rate of change of velocity with time means that v divided by t. Alright? So acceleration can be written as delta v divided by delta t. So this mathematical formula can be descriptively explained as acceleration is the rate of change of velocity with time, or we can say acceleration is the time rate of change of velocity. So velocity divided by time is acceleration. Fine. We can also write this in the form of initial and final velocities. Acceleration is equal to final velocity minus initial velocity divided by time. Okay. Now acceleration is a vector quantity. Why it's a vector quantity? Because acceleration is velocity divided by time. So because velocity is a vector quantity, it has a direction, so as acceleration is a vector quantity because it has a direction too. The SI unit of acceleration is meter per second square. Okay, meter per second square, because the SI unit of velocity is meter per second, and the SI unit of times is the SI unit of time is second. So meter per second, and for time we have second as well, so it gets multiplied with second. So meter divided by second square. So we have SI unit is meter per second square. Moving on, we have discussed few types of acceleration. The first one is uniform acceleration. So when velocity changes by equal amounts in equal time intervals, so we call it uniform acceleration. All right. For example, the velocity is constantly increasing with time, but linearly. So the linear increase in velocity is known as uniform acceleration. Velocity starts from 0, and the velocity gradually increases like this to 10 meters per second or 20 meters per second, but linear increase. So this is uniform acceleration. In variable acceleration, the rate of change of velocity itself keeps changing. So here again, the velocity is changing with time. The velocity gets changed with time, but the change is not uniform. It's variable change. Sometimes the velocity gets too high, sometimes it gets a bit low. So acceleration is there, but it is variable acceleration. Okay. Next is retardation, or we can call it negative acceleration, or we can also call it deceleration. So acceleration opposite to the direction of motion that slows the object down is known as retardation. So we can also say that when the velocity is decreasing, if the velocity is decreasing, then in that case we have negative acceleration or we have retardation. Next we have zero acceleration. So zero acceleration is when the velocity stays constant. So if the velocity stays constant, then acceleration will be zero. We can see it from the equation here. Acceleration is equal to final velocity minus initial velocity divided by time. So if the velocity is constant, then final velocity and initial velocity will be the same. So this term gets 0, so acceleration will be 0. Okay. Now we have an example over here. A car goes from 10 meters per second. So this is initial velocity u. Okay. A car goes from this velocity 10 meters per second to 25 meters per second. So this is our final velocity v in 5 seconds. So find the acceleration. So we can find the acceleration using this formula, v minus u divided by t. So v minus u is 25 minus 10 divided by 5 seconds. This gives us 3 meter per second square. So this is an example of uniform acceleration, because acceleration is constant and the velocity has increased from 10 meters per second to 25 meters per second. So this is positive acceleration or uniform acceleration. Okay. Now moving to next slide, we have the graphical representation of acceleration. Okay. So the graphical acceleration basically is based on two rules. In this graph, we can see on the horizontal axis we have time axis, and on vertical axis we have the velocity. Okay. So the slope of a velocity time graph, this is a velocity time graph. Okay. So the slope of a velocity time graph gives us the acceleration at that instant. Slope means velocity divided by time here. In this case, the slope will be velocity divided by time, because velocity is on vertical axis and time is on horizontal axis. So slope is always vertical axis divided by the horizontal axis. So the slope of the VT graph gives us acceleration. Okay. And second rule is the area enclosed between a velocity time graph. This is velocity, this is time, and this is velocity time graph. This is the area enclosed beneath this point and this point. So this is the area enclosed by the velocity time graph. Okay, this whole, this is the area enclosed by the velocity time graph. So the area enclosed between the velocity time graph and the time axis gives the displacement. Okay. So the slope gives us the acceleration. The slope of velocity time graph gives us acceleration, while the area under this slope gives us the displacement. Okay, displacement can be written as S is equal to, S shows displacement, S is equal to velocity multiplied by time t. Alright, so to summarize this slide, we have acceleration, which is the slope of velocity and time graph, and then we have displacement, which is the area under the velocity time graph. So slope is equal to delta v divided by delta t is equal to acceleration, while the area enclosed by this graph is equal to displacement, S is equal to vt. Moving on to our next slide. Okay, one more thing I'll tell you, that you can get all of these slides that I have prepared, and you can also get the lecture notes of these lectures of this course, of these chapters. You have to comment, and you will be provided with those lecture notes and with those slides, PowerPoint slides as well. I will also paste a link in my description to those lecture notes and slides. Okay, so now we have some different cases of velocity time graph. We have three cases. So looking at the first case, we can see that on a vertical axis we have velocity, on horizontal axis we have time. So as the time moves on, as the time passes by, the velocity stays the same. The velocity is not changing, so we can say this is a case of uniform velocity. So the acceleration will be zero, because in uniform velocity the final and initial velocities will be the same, so acceleration will be zero. Now in second case, this is time on horizontal axis, and this on vertical axis we have velocity. So as the time goes on, the velocity is increasing linearly in a straight line. See, this is a straight line, linearly increasing velocity. So increasing velocity in a straight line with a positive slope tells us that the object is basically accelerating. This is an example of uniform acceleration. Why? Because this is the final velocity, this is initial velocity, we can say v, and this is u. So v is greater than u. Final velocity is higher than initial velocity, so this is positive acceleration, uniform acceleration with a positive slope. The third example shows us that with time the velocity is decreasing. The velocity is actually decreasing. This is our initial velocity u, and this is our final velocity here v. So v is smaller than u. The final velocity is lower than the initial velocity, so this has a negative slope, so it is uniform retardation, or we can say deceleration or negative acceleration. So horizontal line in this case, like here, horizontal line shows us constant velocity with zero acceleration. Straight line, positive slope, as in this case, straight line, positive slope. It shows us constant positive acceleration. And straight line, negative slope, as in this case. Straight line, negative slope. This shows us constant retardation or deceleration. So subscribe to my channel, like this video, and you can ask your questions in comment section as well. Thank you so much.